And then this is your assignment that is on Google Classroom right now, and I believe it's in your packet as well. So, well, like always, if you have questions on it, please ask. On any of this stuff, if I can clarify anything that you need. But that's the assignment that's on Google Classroom. That'll be due Friday again. That's our assignment of the week. It's a short one. I think it's shorter than a weekly, honestly. It's also more everything that we've done in this unit so far, so it shouldn't be too bad. Especially if you're attending and watching these streams, you should be okay. But we're gonna start a new topic. This is not in that assignment as well, so this will be completely new. And it's another rule. This is an important one as well, which is an inscribed angle. 13 and 16 on the homework. All right, let me do those first. 13. Just says that assignment is in the packet. All right, that's good. 13 and 16. So I'll just quickly go over these. So number 13, it says find NK. Let's see, where's NK? Right here. Pythagorean theorem. Because we know it's a right angle, this is a right triangle. Pythagorean theorem. So 15 squared minus 9 squared equals NK squared. So whatever that is going to be. I'm not sure what that's going to be, but I think it's 12. Right, 15 squared. Oh, my Apple Pencil's not working properly right now. Just give me a moment. But it should just be a Pythagorean theorem one. And I think you get 12. Why is there a random point labeled n? That point is there to... it's definitely for number 16 because they say JKN, so it is required to be there. So that point is needed, but that is how I would do number 13 pages. Just do Pythagorean theorem. So 15 squared equals 9 squared plus NK squared. I think it's 12 if I'm doing my mental math good enough, but I think that's how we do it. And then number 16, find the measure of arc JKN. So let's see what JKN looks like. So JKN is, whoops, this guy right here. Let's see how we would figure that one out. So there's nothing saying that, yeah, that's definitely more than half a circle. So we could easily figure out this arc here. But then that remaining arc, I'm not convinced we can find easily. So there might be a typo with this one because I'm not seeing how I would do it. I'm curious what the solution did back here. Let's just take a look at it because there might be something that I'm missing. So they doubled. The 53 sounds fine to me. However, I'm struggling with why you can just subtract that from 360. That is not going to be... That's not correct. This answer key is wrong. I think it's supposed to be J and K. I think that's why. It looks like my video froze. I'll get that up in a bit, but... So there's supposed to be two ends. I don't think there's supposed to be two ends, but I think that's kind of what is going on. But anyway, I'm going to pull up the notes that we're going to do today. So Paige, I wouldn't worry about that one. I'm pretty sure it's a typo. I'm almost positive it's supposed to be J-N-K, which would make a lot more sense. So those letters are just kind of flipped because the way we're doing it, J-K-N, I don't see enough information for us to figure that out. But that's a good catch that you were able to find that. So that's really good. Your packet was just delivered. Perfect timing, I'd say. So that's good. And let's see. There we go. All right, so an inscribed angle is going to be an angle when its vertex is on the circle. And we've done this definition earlier when we did all the definitions and so forth. We've seen it before, but now we're going to start looking a little bit more mathematically on what some of that relationship is going to be. So that's kind of what we're going to be looking at today. So right over here to the side, that is what we see as an inscribed angle. So it's an angle with a vertex on the circle with two sides that are chords. Those chords could be a diameter, it could be something like that, but any two chords that are inside the triangle is going to be an inscribed angle. Just be very careful. It has to be on the circle. So if it's really close to the edge over here, it's just inside the circle, there's really no relevance to an angle like this that's inside the circle. It has to be on the circle. The vertex needs to be on the circle. Okay? So an intercepted arc is the arc that lies between the sides of the inscribed angle. And I've used this terminology before. So when we're talking about an intercepted arc, I've mentioned this terminology with central angles. The intercepted arc is just the angle that's in between the sides, or the arc that's in between. So that is what we would be considering the intercepted arc. So we can even label that in here, intercepted arc. Oops. So if you ever hear me use that terminology, that is what we mean. The degree of the inscribed angle is equal to half the measure of its intercepted arc. So different relationship than central angles. Central angles were just you had a central angle and it was completely congruent to its arc. Now we're going to have this 2-to-1 ratio going on. So we're going to do you're going to double an angle or you're going to cut something in half. That's really the major relationship that we're going to be looking for. So which one is 1/2 of each other? The arc is the one that is twice as big. The angle is the one that's going to be cut in half. So for example, if this arc down here was 100 degrees, that means the inscribed angle where the vertex B is right now, that angle would be 50 degrees. So they can go in either direction with this. If they give you the angle, you need to double it. If they give you the arc, you're going to need to cut it in half. And just kind of going back and forth between these two things. So in our example, so in our example right here, we can say that the measure of angle ABC is 1/2 of arc AC. I just arbitrarily chose 150 as an example. If you wrote 50 degrees in that blank, that's fine. But I'm just kind of putting the rule out there for the inscribed angle. So that's one of the things that we're going to practice. The next one is a big one, and this is a very important concept to be able to kind of determine and see, because they don't give you really any information with it other than a drawing. So if you look in this drawing right here, we have an intercepted diameter, and right here is the diameter. So if it goes through the center of the circle, and then A is the inscribed angle, well, this means it's always going to be a right angle every single time, and it is following the rule of inscribed angles, because BC, arc BC, would be the intercepted arc. BC is a semicircle. It's half a circle. So if it's half a circle, that means it's 180 degrees. Half of 180 is always going to make this a right angle. And it doesn't matter where A would be. If you move point A kind of around that semicircle, it's always going to be some kind of right triangle, no matter what. So if an inscribed angle intercepts a diameter, then it is a right angle. So the measure of angle BAC is equal to 90 degrees. And what's important here is it's just a diagram that's required. Is there a diameter? Do you know if there's a chord that goes through the center of the circle, and you have yourself a 90-degree angle? You could even, if I put a point here and I connect here to here, here to here, this pink triangle that I've created doesn't look like the most elegant triangle, but that is a right triangle because it's still intercepting the diameter. Again, it's not elegant, but that would be a right triangle. As long as it goes to the diameter, it goes to a semicircle. So different ways you can see that. A lot of people having technology issues today. Am I streaming at like a higher setting? I don't think so. I'm not sure. All right, now let's look at overlapping arcs. The internet is bad today. It might be. If it is, you guys can always rewatch this, but hopefully it kind of just... Hopefully everyone's internet kicks in. Okay. Alright, let's take a look at the overlapping arcs. So if two inscribed angles intercept the same arc, then the angles are going to be congruent. And this is another one, and we're going to see this specific rule probably a little bit more closely when it comes to proofs that involve circles, where we have overlapping arcs and we have this congruency thing kind of going on. No surprise we would see it with proofs because, look, we have triangles inside the circle, and we can do everything we can, everything that there is to do with triangles. But what does this really mean? Well, if we take a look at... We have 4 inscribed angles in this diagram. Each point that's on the circle, A, B, C, and D, they're all inscribed angles because they're angles that form on the circle. I'm going to take a look at two of them. I'm going to take a look specifically at A, because let's look at the value. Well, we can't really look at the value, but we can look at the fact that angle A intercepts arc BC. However, so does arc D. It intersects the same exact arc. So therefore, it follows the same exact rules, and it undergoes the same exact mathematics as angle A. Even though we do not know any of the actual values, if you were to plug in any value for these, you're going to get the same thing for angle A and angle D. These must be congruent because it must be half of whatever arc BC is. So, for example, if arc BC were 60 degrees, that would make A 30 and D also 30 because you'd have to cut it in half. They're intercepting the same exact arc, so they're all congruent to each other. Well, the angles are congruent to each other, and they're half of that arc. You get the same thing with B and C. However, there's nothing saying that AD, arc AD, this arc right here, is congruent to arc BC. In fact, they do look a little different, but it does tell me that angle B would be congruent to angle C for the same exact reasons. They're intercepting the same arc, in this case AD. You have two angles which are congruent triangles. You have similar triangles every time this happens in a diagram. You also have vertical angles congruent, I suppose, but that's not really part of what we need to talk about. So that rule is going to be pretty important. If two inscribed angles intercept the same arc, then the angles are congruent to each other. So in this one, it says the measure of angle ABD. So ABD, this is going to be congruent to the measure of angle. So that one's where B. So this one is going to be C. So ACD. So 3 rules when it comes to inscribed angles. Let's just kind of review them before moving on. The first one, I think, is the simplest one. The 2-to-1 ratio. The arc is twice as big as the inscribed angle, or the opposite of that, the angle is half of the intercepted arc. So doubling things, cutting things in half. The diameter in the overlapping arcs one, I think they're overall pretty easy to see and visualize, but they're going to give you very minimal or no information other than a diagram. We need to make these determinations based on a diagram alone, because they're not going to tell you in a given, oh, you have 2 overlapping arcs. You need to see it for yourself and then come up with that conclusion that, oh, this diagram has overlapping arcs. This is what it looks like. These angles are congruent. You also need to recognize if there's a diameter and semicircle in a diagram, any inscribed angle that goes to that diameter or semicircle is a right angle, because they will not tell it to you. They're not going to say, oh, angle A intercepts the diameter. Hint, hint. Guess what that means? They're not going to do that. They're just going to throw the diagram at you, and you need to recognize it based on the diagram. And that's kind of one of the things that I think makes circles a little bit tricky. They try to give you as little information as possible and you to come up with your own conclusions based on what you can see in front of you from the picture. So let's do some practice with that. So number 1, it says find, the directions just say find each angle measure and each arc measure that we have right here. Some diagrams we're going to be able to find out everything. Some of them just give us very minimal information. Number 1, you can only find one thing because they tell me that WY, arc WY is 62 degrees. They want angle X, WXY. I can't find those outside arcs. There's nothing saying that these arcs are congruent. There's not much to do other than what's the relationship between the 62 and right here. And if you ever forget, do I cut it in half? Do I double it? I mean, look at the diagram. If you doubled it, you would get 100 and... was it 144? No, 124. Is that a 124 degree angle? No way. It's acute, so clearly we need to cut it in half. So this angle is 31 degrees. Then right here, it's just the opposite relationship. They gave me the inscribed angle, so now I need to find the intercepted arc. Just be careful on what they're looking for, because this is a case where it probably looks like we could find a few different answers. They want arc DGF. So DGF, that looks fine. That is a direct route to our answer. So all we need to do is double the 113, and we get 226 degrees. Number 3, this is kind of what I was talking about. There's no numbers in the diagram, but I'm kind of observing that, hey, this is a diameter, and Q is the inscribed angle, and it extends to that diameter. That automatically makes angle Q a 90-degree angle, which is exactly what they wanted in this problem, the measure of angle PQR. No numbers on the diagram were needed, but we can come up with the conclusion that that is a 90-degree angle. It is a right angle because of that right there. It's also a semicircle. I mean, I guess we do have some numbers. We know that this arc is 180 degrees because it's exactly half a circle. I mean, that is why we can make that conclusion. Number 4. So in number 4, they're asking for arc BC, which is this one right here, and that's not an intercepted arc. If it were an intercepted arc, we would need an inscribed angle somewhere over here. We don't have that. So we can only work with the one intercepted arc that we do have, which is the 47. So I just got to ask myself, all right, do I double it or cut it in half to get to the arc? If you have the inscribed angle, we double it. So we're going to double that, and that means arc AC, because this is the intercepted arc. That's what the doubling is going to give me. So if I double that, I get 94. But that's not our answer. The answer is whatever arc BC is. But I'm also see that AB is a diameter. So that means the whole arc from B all the way around to here, the semicircle. So that's 180 degrees. So all I need to do is take that 94, subtract it from 180 degrees, and that's going to give me arc BC in this case, which I think is 86. Number 5. So I got a few things here. They want angle JKL, which is the inscribed angle right here. If that's the inscribed angle that I want, they want that inscribed angle. The best way to figure that out is, well, let me figure out the measure of the intercepted arc, which is this one right here. If you know the measure of that purple arc, all we need to do is then cut it in half to get the inscribed angle. So that's how we're going to use the 53 and 65, because collectively that's the full circle. So we're going to add 53 and 65, and that's going to be 118. And we're going to subtract that from 360. So subtracting that, so 360 minus 118 is 242. So that's this big arc all the way out here. Last thing we need to do is cut it in half. So we get 121. Is it just this stream, or is it just your internet today? Is it everyone's? Because if everyone's having the same issue, I think it's a problem on my end. I don't know. Yours fine now. Yours okay. So some people are fine. It hasn't happened since the beginning. Because I know I was having some technology issues in the beginning, but it wasn't internet issues. It was more hardware issues. is bad. Huh. The best thing to do is probably to just rewatch it when this ends, which will probably be around 2 o'clock. I'm not ending. I'm doing calculus today, so it's not going to end for a while. But I think that's kind of the best thing, because I don't think I'm streaming at a higher quality. So, I mean, I don't know. I don't think weather affects internet usage, so I don't know. That's a good point, Ryan. Live streams do use a lot of internet. But going back to the problem, we go to 121 degrees for angle JKL. And now number 6. They want the measure of angle RST. So RST is right here. And they want RUT. And one important thing to note with these two angles is the fact that they're intercepting the same arc. So one thing's for sure. These two answers are exactly the same. So this is an overlapping arc 1. Because this arc and this arc are the same thing. So really the whole goal should be, let's find the value of arc RT, and then all we gotta do is cut it in half. That's all we need to do. And we have all 4 arcs right there. We have 64. We can add 139 and add 75. So we add all those together, the 64 plus 139 plus 75. We get 278. Then we can take that 278 and subtract it from 360 degrees, which I think is 82. So that means arc RT is 82 degrees. And then lastly, what we need to do is just cut that in half to get those two angles in here. So each one of these are 41 degrees each. Again, they're intercepting the same arc. We knew they were going to be congruent. So 41 degrees, 41 degrees. All right. Now let's take a look at some of the ones that require some algebra behind them. So number 7. Number 7, they give us both. We just need to solve for the value of x. We can stop there. No plugging in is required. You have a few options that you can do here. So if you have 158 here, you know what the measure of this angle is. So you can just cut the 158 right in half, and then you're going to have the measure of angle CDE. So that makes CDE, I think that's 79. And if the inscribed angle is 79 and it's 8x minus 9, we could just set these two equal to each other. Oops. And then solve for x from there. Adding 9, we get 88. Divide both sides by 8. We get 11. Number 8. Same thing we could do here. I always like to go with the easiest route. So again, you do have two options. You can either take this angle and double it, which I usually like to work with the number. I either like to double or cut in half the whole number rather than doubling or cutting in half the entire expression. Only because you could just take the expression, you could cut it in half instead of equal to 27. You just got to remember to cut everything in half. So it would be 2x plus 29, which is fine. That is completely acceptable. But I think doubling just the whole number is going to be far easier. Because it's only one number. It's the only thing you need to double. You double 67, you get 134. So you can set 134 degrees equal to 4x plus 58. Which honestly, all this stuff is, at least the algebra component, is nothing new. We've seen this same type of algebra with mid-segments and stuff like that. Anytime we've seen a 2-to-1 ratio, proportionality theorems and stuff like that, we've seen this time and time again. So really, I think we know, or we should know, how expressions are handled whenever we're cutting them in half or doubling them or whatever. Because we've been doing it for a long time. And you've been doing it well before this class as well. So just kind of quickly going through the algebra, 134 minus 58 is 76, and then we're going to divide that by 4, which is 19. Yeah, 19. And so far that's inscribed angles. Just another rule to kind of throw at you. I would say that this rule comes up far more often with circles than yesterday's congruent chords do. Inscribed angles is a pretty important rule, mainly because there's 3 rules kind of tied into the whole overarching topic of the whole thing. The intercepting diameter, overlapping arcs, and this 2-to-1 ratio concept. We'll keep on going to see some different ones, ones that are a little bit more challenging. We're definitely not going to finish all of this tomorrow, because I think this is a pretty important topic. We will start off tomorrow's stream by covering a few of these, just because I think it's important. I think it's better to see this over more than just one day. So we'll do some more challenging ones tomorrow, like the ones at the bottom of the page. And just don't forget that we have a stream tomorrow, but I'm not doing one on Thursday, just to kind of throw that out there, because we do have a meeting. All the faculty does. Whoops. Definitely utilize that time, though, to work on that assignment. All right, so in number 9, they just give you this 13x minus 1. So if they just give you the 13x minus 1, no arcs, well, that's a good indication that usually you can figure something out on your own. And we definitely can, because the inscribed angle is going right across this diameter right here. That's the right angle. So the expression, this 13x minus 1, is actually pointing to a 90-degree angle. So we just got to take 13x minus 1, and we're going to set that equal to 90 degrees. We're going to add 1 to both sides. And we get 13x equals 91. We're going to divide by 13. And 91 divided by 13 is 7. And that's all we need to do. It just says solve for x. All right, number 10. Solve for x. And they're giving me a little bit more information in here. So this one, obviously, there's no 90-degree angles in this one. They want me to find the value of x, and that is this angle right here where we have w. And if I look at the inscribed angle to w, that's this guy right here, which we don't have any direct information about that arc. So I can't set up an equation right now because I don't know the value of that arc. So my goal should be, all right, let's use the information that I haven't really looked at yet, that 114 and that 78, and see how I can find the value of that arc. So the 78, I'm actually seeing two different ways I could do this. I can use all the arc measures of the circle, but I'm going to go with the easiest way. And the easiest way is we're going to use the 78 because angle Y is an inscribed angle. And if angle Y is an inscribed angle, well, all we can do to figure out that angle is, well, the 78's right there. Let's just cut that in half to figure out what angle Y is, which in this case would be 39. And then you have a triangle. And now you can just add up the two angles to figure out the angle that's missing, and then you'll have the value of angle W. And once you have angle W, you can set that equal to 7x plus 6. So we're going to add the 114 plus 39, and you get 153. So the sum of those two angles is 153. We're going to subtract that from 180 because the three angles on a triangle add up to that. We do that and we get 27. So that tells me that angle W is 27 degrees. It is also 7x plus 6. So that's a great opportunity. Now we can find the value of x by setting them equal to each other. So 7x plus 6 is equal to 27 degrees. So we're going to subtract 6 from both sides. We get 7x equals 21. Divide both sides by 7. And we get a final answer of x is equal to 3. Which I think is a good one to end the stream on. I only have about a minute left. So if there are any questions, please let me know. Like I said, I am going to practice some more of these tomorrow, just because I think it is an important concept. We do have another thing to go over, which is inscribed quadrilaterals. So if you're going to be looking at the homework, just for additional practice, there's probably a lot of questions on here you might not be able to answer just yet. So, I mean, you can probably answer maybe the first page, but there might be a point where you get stuck. You might be able to figure a lot of it out on your own, too. But by all means, you may practice it. I'm not assigning it formally. You guys already have an assignment. I'm never going to assign more than one thing at a time. I'm going to try really hard not to. Yeah, I know, if we were in school, you'd have weeklies and homeworks and quizzes the next day, but since we're doing it this way, only one assignment at a time, and you guys have that assignment on Google Classroom already. And I think I'm giving you guys more than enough time to complete each one. If there's any questions on any of that, let me know. Other than that, though, we're all set. Thanks for tuning in today, and I'll see you all tomorrow.